So we've come to the last topic of Chapter 19, limiting reactants, and this is something that we're familiar with. We did this back in Chapter 6. So all we're doing is adding in gas laws to this, okay? Now the pattern for all stoichiometry problems are the same. You're trying to find out which ingredient you're going to run out of first, okay? So the example I gave is if you're baking cookies, are you going to run out of flour, eggs, butter, sugar? What are you going to run out of first, okay? Because whatever you run out of first, your reaction's done. Once you run out of eggs, you can't make any more cookies. Once you run out of flour, you can't make any more cookies. And like I said, this pattern is always the same. You start with your known, and you're going to convert to moles of known. Now, how do you go from your known to your moles of known? It depends on what they give you. If it's in grams, you convert to moles of known using the molar mass. If they give you milliliters of solution, you convert to moles of known using molarity. And now we're adding another branch to this. If your known is in liters of a gas, then you're going to use PV equals nRT to get it to moles. And after the algebra, it looks like that. PV equals nRT is how you would convert it to moles. Or if you're lucky enough and you're at STP, then you can use the 22.4 liter conversion is equal to 1 mole. So now we have three possibilities. 1, 2, 3 different ways you can convert into moles. Once you have it into moles, the second step is to convert to moles of the unknown. And there's only one way to do this, and that is to use the mole ratio. And then the third step is to convert to your unknown and there are 3 ways to do this. It's the same 3 ways as above. If they want their answer in grams, you're going to use the molar mass. If they want their answer in milliliters of solution, then you're going to use molarity. And if they want their answer in liters of a gas, then you will use PV equals nRT. And for trying to get to volume, the algebra would then change to I can make a better R than that. Okay? So there are three different ways to convert to your unknown. Okay? So it may seem like the problem is different, but in reality, the same 3 steps occur. You go from your known to moles of unknown, to moles of known, and then to your unknown. Okay? So those 3 steps are the same in every single problem. What you're given and what you end with are going to be different. Okay? So we'll start with a few easy problems, and then in the second video I'm going to make some challenge problems that are extra credit, but I'll start with the problems that I would expect you to be able to do. These are the problems that would be on the quiz. The challenge problems will not be on the quiz. Alright, so let's start with a gas law problem. How many let's see, how many grams of water will be produced when let's say 15 liters of methane gas react with 60 liters of oxygen gas. Okay, so this is a combustion reaction. So the first thing we have to do is write out our reaction. Methane plus oxygen. When it combusts, it will produce carbon dioxide and water vapor. This is the reaction that occurs in your furnace. Okay, these are all gases. Gas, 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 gas. I've got 15 liters of methane, and I got 60 liters of oxygen. I want to know how many grams of water are produced. And I need to balance my reaction. So in order to balance it, I'm going to need a 2 here and a 2 there. Now my reaction is balanced. Because I have 2 reactants, methane and oxygen, I will have to work out 2 problems. Okay? So I'm just going to start with the methane. And I've got 15 liters of methane. I'm going to do this at STP because I want to make the problem easier. Okay? So if I'm at STP, I know that 22.4 liters is 1 mole. Okay? So I do that to get to my moles of methane. So that's the first step. If I go back and I look at my flow chart, the first step is to convert to my moles of known. Okay? And I'm doing that using the 22.4 liters. Then my second step is to use the mole ratio. For every 1 mole of methane, I will produce 2 moles of water vapor. Okay? And then my third step is to convert to your unknown. And in this case, I want grams. So how do I convert to grams? I use the molar mass. So for every 1 mole of water, it will weigh 18 grams. How did I come up with that? I added up oxygen, which weighs 16, hydrogen, which weighs 1, and there's 2 of them. So now I'm ready to plug it in, and I get the answer of 24.1 grams of water. Okay. Now I have to do the exact same thing for the oxygen, because I have to see which one am I going to run out of first. Am I going to run out of methane first, or am I going to run out of oxygen first? So I go back and I redo the exact problem, but this time I'm using oxygen. Okay. For whatever reason, people always seem to confuse, and they go back and they find the carbon dioxide. We don't care about the carbon dioxide. The problem asks about the water. Okay, so I'm still converting to grams of water. We don't care anything about the carbon dioxide. So since I'm at STP, 22.4 liters is equal to 1 mole. Second step is to use the mole ratio. And the ratio here is 2 to 2. Okay? So for every 2 moles of oxygen, I will get 2 moles of water. And then the last step is to convert from moles to grams. And again, water still weighs 18. Put this into my calculator. And I get 48.2 grams. At this point, I pick which one is smaller. Is this answer smaller? Or is this answer smaller? Whichever one is smaller, that is the correct answer. So the smallest answer is this one. So the final answer would be 24.1 grams of water will be produced. Okay? Now, if you don't know, when your furnace works, it is producing water. And so what happens to that water vapor? There's actually a tube that runs out of your furnace for the condensed water. So the gaseous water condenses into liquid water. So you'll probably notice on your furnace when it runs, a little bit of water trickles out. Okay? Same thing happens with your air conditioner, but for a different reason. All right, let's do one more example problem. Okay? In fact, maybe we'll do 2 more example problems. Okay. How much carbon dioxide is produced when, let's see, 928 grams of gasoline reacts with 120 liters of oxygen at STP. Okay? So first thing we got to do is balance the reaction. The formula for gasoline is C8H18. You're not expected to know that, but that's the formula of gasoline. Reacting with oxygen, anytime you combust a hydrocarbon, you always get CO2 and water vapor out. Okay? And in this case, I'm curious about the grams of carbon dioxide. How much carbon dioxide am I producing? Okay? So, actually, let's find the liters of carbon dioxide instead of grams. Okay? How many liters of carbon dioxide are produced? So I'm given grams here, and I'm given liters here. So I'm going to have to work out 2 problems to figure out which one am I going to run out of first, the gasoline or the oxygen. Which one? Okay, so let's first start with the oxygen. Okay, so I've got 120 liters. Okay, so how do I get this to moles? Well, since I'm at STP, 22.4 liters is 1 mole, okay, of oxygen. Once I get it into moles, then I can use the mole ratio. And unfortunately, I forgot to balance the reaction. So let's balance it real quick here. I have to have an 8 there, so that I have 8 carbons. I'm going to need a 9 here, so that I have 18 hydrogens on each side. And that means I'm going to end up having 16 plus 9, which is 25. So I'm going to need a 25 halves right there. That's going to get me a balanced reaction. Okay? So once I have it into moles, my next step is to use the mole ratio. And for every 25 halves, another way to express 25 halves is 12.5. So for every 12.5 moles of oxygen, I will produce 8 moles of carbon dioxide gas. And then the last step is to convert to liters. So for every 1 mole, I will produce 22.4 liters. That's at STP. Okay? Now, in the video on mass to volume, you may remember that if the temperature doesn't change in the problem, these things cancel, and all you have to do is use the mole ratio. So I just wanted to show you that again. When we were doing this problem, during the reaction, did the temperature change? No. Now this is very basic chemistry. When you get advanced stuff, obviously the temperature changes. When you burn gasoline, it creates heat and the temperature is going to change. But for basic chemistry, we're pretending right now that the temperature and the pressure don't change. So when I put this into my calculator, I get 76.8 liters of CO2. Okay. Now I have to do the problem over again, but this time I'm going to use the gasoline. So how much did I have? 928 grams. 928 grams of gasoline. How do you convert grams into moles? Use the molar mass. So there are 12 carbons. I'm sorry, carbon weighs 12. There's 8 of them. Hydrogen weighs 1. There's 18 of them. So the molar mass of gasoline is 114. Second step, use the mole ratio. So I have to go back to my reaction, and the ratio is 1 to 8. Okay, 1 to 8. So for every 1 mole of gasoline, I'm going to produce 8 moles of carbon dioxide. Okay? And then the last step is to convert back into what you're trying to find. In this case, I'm trying to find liters of a gas. So for every 1 mole of a gas, I'm going to produce 22.4 liters. So I plug it into my calculator, and I get 1,458 liters of carbon dioxide. Okay? So we picked the one that is smaller as our correct answer. So which one is smaller? This one is smaller. So the correct answer is 76.8. Now let's tie this into percent yield, because it's been a while since we've done that. Percent yield is what you actually got over what you theoretically could have had. So I know the example I always gave was cookies. You know, the recipe says that you should get 24 cookies. That's the theoretical. So if you follow the recipe, you should get 24 cookies out. But you never get 24 cookies out. Why? Because there's always batter left on the spatula, in the bowl, and you always snitch a little cookie dough anyhow. So you never end up with what they say you should. Okay? So in our problem, we theoretically should have gotten 76.8 liters. In part B of the problem, they'll say 35.8 liters of CO2 were produced. What is the percent yield? So what you would do is you take what you actually got and divide it by what you could have gotten theoretically, which is the 76.8, and then you multiply it by 100% to find your yield. And so you get 46.6% yield. Okay, so you will see a couple of these questions and a percent yield question on the quiz. Okay, and then I'm going to do an optional video for more advanced limiting reactant problems where we throw in molarity and things that are not at STP. Okay, so I would highly recommend watching that video, even though it's optional, because that's what will be expected at you to be able to do well at the next level. I would have normally taught that to you had we been meeting face to face, but I want to try to keep it a little bit more simple for you, so I'm leaving that out, even though had we been having class, I would have taught it to you.